Alright, so now that you've created the Titan projects, the next step is to learn how to turn these projects into a file that a machine can cut out. And what we're going to do is we're going to do the Titan-1M here, and then you're going to make it on our Tormach mill. So what I'm going to do is I'm going to walk you through all those steps, and this is going to be a version similar to what the Titans of CNC Academy does, just edited for how we do things in our shop. So shout out to them for creating this education and letting us use it. Couldn't do it without you guys. So first thing we're going to do is we need to set up our machine. We need to do a setup, and we need to set up the stock and the orientation of that stock in the mill so it knows where to start and which direction's what and all those good things. So first thing we're going to do is we're going to click on Design, Manufacture, and we're going to go to the Manufacture workspace. So to create a new setup, we can either click on this setup folder here or go setup, new setup, and it creates what you see here. So we've got our setup dialog box over here, which we're going to do all our things in, all our edits, all our changes. And we can see the stock is showing up as this sort of brownish color, and our part is transparent inside it. You'll notice that right smack dab in the middle is the X, Y, and Z arrows, red, green, blue, that show us how it sees our part within the mill. Right now it shows our material and our part in the mill more or less the way it should, as in Z is pointing to the sky, Y is pointing to the back of the part, and X is pointing to the right of the part, as our view cube shows. The only change I want to do is we always, when we're using the mill, almost always, our start point is not in the middle, but it's going to be in the upper left corner. And on the first op, where we start from a piece of raw stock, nothing happened, we generally use the top left corner of the stock as our point. Now, in order to set up our stock, we need to have our orientation set up. Now, if Fusion was set up properly from the start of your drawing, your XYZ should look like mine. But just in case it doesn't, I'm going to show you how to set that up. So if yours doesn't look like mine, to change that, all you need to do is come over to the Setup dialog box where it says Orientation. You're going to change that from Model Orientation to Select Z-axis and X-axis. So what we're going to do is we're just going to tell it, this is the direction I want you to face. So for our Z-axis, we're going to click on Select. It's already blue. It's already telling us we need to do that. And what I'm going to do is I'm just going to find an edge on my part that points in the same direction. So I want it to point to the sky. So I'll just come in and I'll click on this edge here. And now it points to the sky. Mine didn't change because mine was previously set, but if yours wasn't, then now it is. It asks us to select our X-axis, which is going to be left to right, so I'm just going to click on this edge. And now our arrow changes a little bit. The X is pointing in the wrong direction, the Y is pointing in the wrong direction. So, easy to fix. We'll just flip our X-axis, and now everything looks good. So, orientation, colors of the arrows are pointing the right direction, but we want to move it over to the upper left corner of our stock. So we'll come down here to where it says Origin. It says Stock Box Point, which is correct, although if we wanted to, we could use any of these. We're going to use Stock Box Point, and we're going to click Box Point, and then all these white dots show up. These white points are what we want to select. So I'm just going to rotate this around, and we want our upper left corner, which is right here. I'll zoom in, and I'm going to left click on it, and now our orientation arrows show up stuck to that corner. And that's perfect. Now we have told the program, and it will tell the mill that we want to start from the upper left corner, and that's the directions of travel, with the arrows pointing where they are. So now we'll go to stock, and we'll set up our stock. Right now it's set up to the relative mode, where it's going to add a little bit of material to all the sides that have material set. So sides and the top. We're going to change this to fixed stock because we have a fixed piece of material. You're going to cut a piece of material, and you should cut it to 4 1/8 because we want a little bit of material. So 4.125, and that's going to add a little bit of material to the left and right of our part. If I click on the front, we can see that there's a little bit of material there and a little bit of material there. Our depth Y needs to be 2, which it's already got. And if we look at the right, again, a little bit of material on either side to take off. But for our height, we need to make some changes. Yes, we want 1 inch in height, but right now it's positioning that part in the center. All right, it was in the center of left to right, center front to back, and it's at center top to bottom. We don't want that. There's not enough material to hold onto our part on the bottom. We want to be able to hold onto their part at the bottom with a whole bunch of material and a little bit on top just to take off, clean up, and make look perfect. So we're going to change our model position from center to offset from top, and then we're going to tell it exactly how much. I want to offset 0.02. 20 thousandths is all we need for it to be have enough to face off, remove, clean up, make look pretty, and then a big chunk at the bottom here to hold on to with the vise. So with that, we can go back to our home view, we can hit OK, and now we have our setup all done and ready to go. So now that we have our setup done, our next step is going to be setting up a bunch of tools and tool paths to make our part. Before we get there though, I do want to bring your attention to the fact that we have put a chamfer on all these edges, on all the edges on the top, the bottom, and this guy right here. And that's just to break the edge so that we don't cut ourselves when we handle the part. So those chamfers are great, but they become a little bit of a problem for us when we start learning how to do these things in the manufacture side of the Fusion. So what we're going to do is we're just going to come up to our workspace and go back to design, and we're just going to remove those chamfers. Easiest way to do that is to come down your timeline and click on chamfer and just delete it. And now they're gone. And we don't have to fight those. So we'll go back to manufacture. By the way, we should save our stuff because it's been a little bit. And notice how there's an error. And that error is because something has changed and we need to fix that. So I'm going to right click on it and I'm going to click on generate. And it says no operation needs to be generated. So that means there's an error. Something has changed. And notice how our X, Y, and Z is down in this corner now, and that's not where we wanted it. So that's what it's telling us is the problem. And the reason for that is we deleted the chamfer and we need to correct something. So we're going to come back in here, we're going to right click, we're going to edit, and it says this operation has some missing references. Do you want to clear those? I'm just going to click no. And what it's telling us is that the x-axis edge is missing. Now why would it be missing? It's because we used that edge and that was a chamfered edge. We deleted the chamfered edge, So it's going, hey, I don't have something. What do I do? So we're just going to clear it. We're going to then select it again. And now it recognizes it. And it's all back to normal, back up here. And if it wasn't back up there, we could just do what we did with the box point. And we'll hit OK. So just remember, when you change things, it affects other things. All right, so we're going to get started here with our facing operation. That's what we're going to do to remove the top surface down to our part. That is, we're going to remove this little bit of material from the top of our stock to the top of our material. So to do that, we are going to come up to 2D, left click, and we're going to come down and we're going to click on face. Everything's a left click at this point unless I say right click. And hopefully I remember to do that. So now we have our facing dialog box up. And every dialog box for tools have tabs. These tabs vary. There's a tool tab, a geometry tab, a heights tab. Every tool is going to have these. There may be a fifth axis tab, which we ignore. There's going to be a passes tab and a linking tab. So we're going to start with tool. We need to select a tool. So to do that, we're going to click on select. I mean, it doesn't look anything like that, but it's just what Fusion shows. And we're going to click on select. Now when we click on select, it's going to now tell us our tool is right here. We do want flood coolant on, which is good. And all of our presets for this tool are here. And they look pretty good. So we're just going to leave our feeds and speeds. Feeds being how fast it moves, left, right, front, back, up, down. And speeds being how fast it rotates, the spindle speed. So what we're going to do now is we're going to click on geometry. And it already recognizes our part, and it's put an orange box around it, so we don't need to change anything here. We're going to click on heights. Our heights, we have these defaults that it brings up, and we're going to change our defaults to stock top, stock top, stock top, stock top, and stock top. Generally, we change all of these to stock top. We will be changing some of them to different things. For example, actually I want this to be model top, but in general we do have to set these up. 0.4, 0.2, 0.1, 0, and 0 for our heights. So everything looks good here. We can click on passes tab. Everything looks pretty good here, especially tolerance. Because we want this to be, when it's done, be our finished tops of our part. We want to make sure we have 3 zeros. This is going to give us a higher tolerance. So that's going to be 4 10,000ths of an inch. And the only thing we want to do, though, is we want to change and we want to enable multiple depths here, because I don't want to take 20 thousandths off in a full pass. Our Tormach is a nice machine, but we want to take it easy. So we don't want to do 20 thousandths in one pass. We want to do 10 thousandths, 0.01 of a pass. And so it's going to do that. If there's 20 thou to remove, I'm going to set our maximum step down, the maximum amount it can cut, to 10 thousandths, and that way it will do it in 2 passes that it can handle. So that's good. Linking, there isn't anything really to change here, so we're going to hit OK. And now it's generated our tool path. We have blue lines. Blue lines are the tool paths that it's cutting, and it's using cutting feed rate. Green and yellow are movements in the air where it's not cutting, and it's using a different feed rate for that. So if we look at it from the front view, we can see that there's the first tool path is here, the next cut is here. It's not showing our stock yet, but what we're going to do is we're going to come up and we're going to go to simulate, and now we're going to hit play, and it's going to make our first cut and then our second cut, and we see our part just kind of at the very top. So if I look at it from the front view and hit play, I'm going to pause it, and we can see that it's removing the first pass down to 20 thou, and then when it comes back on our second pass, it's touching the top of our part. And there we go. So we've just created our first tool path, tool 2 facing. We'll hit exit for a simulation. We'll save our work, and then we'll move on to our next tool. So now that we've got the top faced off, it's time to create our pocket. This is what we call a pocket, and this one here is a cutout. We're going to handle it in 2 ways. First, we're going to rough it out, which we do with an end mill in this case, and we're going to leave a little bit of material on the bottom and the sides because roughing is done quickly, but it leaves a poor surface finish. We're then going to come in with a finishing tool. It'll be the same end mill, but we'll do a contour and a pocket to clean everything up and give it a nice surface finish. We're going to do that with tool number 4, my designated aluminum end mill. It's a YG1 AlumaCut 3-flute center cutting end mill. It has a 5/8 inch long flute, so the most it can cut is 5/8 of an inch. But we're going to back that off a little bit, and we're going to cut it no more than a ½ inch at a time, which is going to mean we're going to need to do multiple depths, since this entire thickness of this part is 3/4 of an inch. So anyway, since time is money, we're going to use a 3D adaptive clearing toolpath. Adaptive clearing is a toolpath that ensures the cutter takes the same bite of material each time as to not shock the tool, as well as the motions are going to be smooth. They're not going to be sharp turns, which also shocks the tool and can cause it to break. This allows us to run faster and produce parts quicker because we can take a deeper cut with a consistent chip. So we'll come up here and we'll select 3D, and we'll click on adaptive clearing. And it's going to bring up our adaptive clearing dialog box. First thing we'll notice is that it's gone and put in the tool from the previous tool path, which is the face mill, the fly cutter, which we do not want. So we're going to click on select. We're going to go to cloud and aluminum, and we're going to find tool number 4, which is my tool for this particular job, and we're going to click on it and click select, and it's going to bring up all these tool feeds and speeds. Now most of the feeds and speeds shown are good, but we are going to change ramp. Ramp feed rate, ramp feed rate set to 5. That's really slow. We're going to change that to 15. Cutting feed rate is set to 30.6 inches per minute. That's just been done using the spindle speed and the surface speed, doing some math. But cutting is when it's doing. It's cutting. The difference between cutting feed rate and ramping feed rate. Ramping feed rate is when the cutter moves down into the material. We don't want to plunge straight down like a drill bit at the drill press. That would be bad. It would probably cause the end mill to crash, It doesn't like to do that. So what we're going to do is we're going to cut down as we move left and right, and that's called ramping. So 5 is really slow. We're going to move it to about 15. We also want to make sure coolant's set to flood, which is good. So the next thing we're going to do is move to the geometry tab. And note that rest machining should be checked and should be set from previous operation and be 20 thousandths of an inch. Remember that we had 20 thousandths of material that we faced off. We don't want this end mill thinking that that material is still there in this adaptive cut. So if we click rest machining, it looks and goes, oh, yeah, you did remove that material. You removed 20 thousandths of it in the previous operation. So that way we don't cut material that isn't there. So now we're going to go to the heights tab. And you're going to do this for every tool pretty much moving forward. All right, everything needs to be changed to model top now. We're working off the model top because we removed all the material with the facing tool path. And some people work from the model bottom. I like working from the model top. This is one of the things that I learned from Titans of CNC, which has really helped out, is if you work from the model top, you're going to have less crashes because the end mill isn't going to work from the bottom up where material can be in the way and you can have a bad experience. So everything's changed to model top. We're also going to go 0.4, 0.2, and 0.1. And now we can select our bottom height. Our bottom height is the full depth of cut. So usually that would be the thickness of your part, which is 0.75. We do need to go negative to go down. But the thing is that for later operations, it's going to be better if we go a little bit deeper. So we're going to go down negative 0.76. And that's going to give us a little bit more clearance later on for some operations. Now, next we're going to go to passes, and we need to change a few things here. Our optimal load is how thick of a chip our tool is going to take. And we don't want to break our tool by taking too heavy of a bite. So what we're going to do is we're going to change this, and we're just going to enter a formula. We're going to enter our tool diameter, 0.25, quarter inch. We're going to use star, which is the multiplication symbol, and we're going to type 0.2 for 20%. A good starting recipe for adaptive tool paths is 20% of the tool diameter. And there we go. That's going to set our optimal load. If we hit OK and came back in there, it would do the math for us and it would be a number. We also want to set our max roughing step down. This is how deep it can cut in each pass. Remember I said our tool is 5/8 of an inch, but we want to cut a little less. 0.5. That's going to make sure we cut a little bit less. So make sure that stock to leave is selected as well. It's a roughing tool path. We want to leave a little bit of material to come in and clean up later. So we're going to make sure we leave 10 thousandths to both the sides and 10 thousandths to the bottoms. So axial stock is bottom, radial stock is sides. And that's going to leave that little bit behind for us to clean up later. We're going to go to the linking tab now, and we're going to change a few things here. So what I want to do is come down to stay down level, and we're going to change that to 70%. It's just going to help us run a little faster. We want to make sure we're going to change our lift height to 0. And the last thing we're going to look at is our no engagement feed rate. This is when the cutter isn't actually cutting. We don't want it to move 30.6 inches per minute if it's just moving around and not cutting. Let's speed that up since we can. Our maximum speed X and Y on the Tormach is 110 inches per minute for X and Y and 90 for Z. So let's set this to 80 inches per minute. Not quite the maximum speed, so that'll help us out. Lead-ins and transitions, lead-in, lead-out. We're going to change this. We're going to set our lead-in, lead-outs to 0.15. Just give us a better cut. And we're going to come down to our ramp. We want to make sure it's set to helix. As I told you before, when it does this pocket, it's going to go round and round, and as it goes round and round in the helix, it's going to go down a little bit on each trip around, less likely to crash. We can change this to 4, speed things up. We don't need a taper angle, so we're going to hit 0. Our clearance height is good, but our ramp diameter, our maximum ramp diameter, we want that to be a little less than the tool. We could leave it at 0.2375, but I know from experience on previous files 0.225 is better. And we want our minimum ramp to be 0.2, again from previous experience. And that's everything. So let's hit OK. Watch it set up and create our tool paths. It's doing it right here. It's thinking, there we go. And now we've got all our tool paths. Everything is ready to go. So let's, per usual, hit save. Because if it's going to crash, it's going to crash when we simulate it. And now we're going to watch what it does. So we're going to hit, I'm going to slow it down a little bit here. I'm going to hit play. So the tool is going to come down away from the material. It's going to come in, and it's now going around, and it's taking material off. It's going to take off that 20% chip of the tool diameter, and it's going to make its way around. It's doing it at a depth of a 1/2 inch because we told it don't cut any more than a 1/2 inch depth in a single pass. So once it's gone all the way around, it's going to then move back and work on this cutout here. So it's going to take, like I said, a 20% chip, and just each time, and it's always going in that direction because we told it to only go in one direction. We can't cut both ways, but you get a better cut feeding it in this direction. All right, so it's done that. Now it's going to move in, and here's the helix, round and round, and it's going to go down a little bit, 4 degrees per revolution, round and round and round. Chips are flying everywhere. Once it gets to a 1/2 inch depth, it's going to start cutting out like it is right now. So when I said it cuts in this direction, it cuts better. It's called conventional versus climb milling, and just one direction gives a better finish, and it's automatically going to do it in that one. There's a lot more to machining than we're learning right now. Just know there's a reason. So it's going to go and get that corner. I'm just going to speed it up here a little bit. And it's notice that it left this spot here. It's going to do this in whichever order it thinks is fastest. It might not look that way to us, but trust me, it thinks it's faster. All right. Now it's going to come up out of the stock to our clearance height so it doesn't crash. Come over, come down, and it's going to remove that. Now it's going to go and it's going to do the outside again, but it's going to do it at the full 3/4 inch depth, right? Because we can't do a full pass. We can only cut a 1/2 inch at a time. So now it's done that, and it's going to come in and it's going to do the same thing on these guys, and it's going to finish it up to its full depth. Let's speed it up a little bit. Again, same thing. Do. And there we go. So now it's roughed out the part. Exit simulation. How long does that take? We can right click and we can come down and we can look at machining time, and it'll tell you that that's going to take 9 minutes and 16 seconds at that speed. All right, let's save it. Oh, we already saved it. And there we go, roughing done. Okay, so now that roughing is done, we need to finish the part. As far as the milling, and then we'll get on to the drilling and tapping. So there's material left on all of these faces, as well as the bottoms of the cutout in the pocket. So what we're going to do to fit, first of all, is we're going to clean up the outside using a contour. So it's going to go around the outside of the part and clean it up. So we're going to go to 2D, and we're going to do 2D contour. And now we've got our 2D contour dialog box open, and it's using the previous tool, which in this case we do want, so we're going to leave that there. Feeds and speeds are good, so we'll go to our default geometry tab, and we're going to click on the bottom of our part. And it's got a blue box now, and this red arrow is on the outside. And it's recognized that that edge can in fact be contoured. The red arrow, by the way, most of the time Fusion gets it right. Sometimes it'll show up on the inside of your cut. And it's up to you to know which it should be. If the arrow is on the inside, it's going to cut on the inside of that box, which is going to ruin our part. So what we're going to do is we want to make sure it's on the outside. Of course, we got to flop over, grab it. Now it's on the outside, and now it's going to cut where we want it to. So anyway, we don't need rest machining or anything, so we're good. So we're going to click on our heights tab. As always, change this to model top. I wish you could just set it as a default, but we can't. Whoops. Model top, model top, model top, 0.4, 0.2, 0.1, 0. And our bottom height on this one is going to be the same as it was in our roughing. Negative 0.76. Our part, we got to go down 0.75 plus that little bit of extra we wanted for clearance. That's all we got to do here. Go to passes. Now our tolerance, we want to make sure that it's 4/10,000ths because we want a good finish. Let's see, what else do we have to set? We're going to click multiple depths because we can't go all in one step. Once again, our maximum roughing depth is going to be 0.5. So that's going to not exceed our flute length. We don't need to worry about anything else here. This is the multi-axis, the fifth axis. We're just going to skip that, go to linking. And this is where we're going to change some of our leads and transitions. It gives us a better finish. Right now it's at 90 degrees, which means the tool is going to go straight in and over. That can sometimes leave a tool mark. So we're going to change that to a sweep angle of 45. That's going to help with that. And we're going to change the linear lead in to 0.1. And our vertical lead in radius to 0. That's going to give us a much better lead in. So the only thing left to do is going to be position. Where do we want our tool to start? Often Fusion likes to stick the tool in the back, and it comes down behind the part, engages the material, and goes around. I don't like it when tools come down where I can't see them, so that it could crash. So what I want to do is I want to tell it a preferred lead-in position. So I'm going to select here. So let's select an edge. Get selected a point, hit OK. But now it's going to start right here in the front. So we've got our tool path going around. Let's simulate it and see what we have. Hit play. Comes down right where we want it to. It goes around. Wonderful. And looking good. Perfect. We've now finished that outside with a contour. Exit our simulation. Let's hit save. Okay. Perfect. The next step is to clean up the pocket and the cutout here. Remember, we've got material on the bottom and on the sides. So to do that, we're going to come up to 2D and we're going to do 2D pocket. And so here it shows up in our browser, and here's a dialog box. So just like before, we're going to use tool 4, so we're good there. We need to go to heights, or correction, geometry, and we need to click on where we want it. So the easiest way is to click on the floor of the pocket, and it's all turned blue, and it's going to cut there. Going to do the same thing here for a cutout. Awesome. Now we go to heights, and we're going to change everything to model top. And 0.4, 0.2, 0.1, 0, and our bottom height is going to be negative 0.5 because that's how deep our pocket is. And that's the deepest it can cut if we set it there. Notice how it says negative 0.52 here. Some of you might notice that and wonder what that's about. Remember, that why is it not 0.5? Why is it 0.52? Well, that's the 20 thou that existed on the top of the part. So that's why that is there. All right, over to passes. Now, tolerance. I want my tolerance to be more than 4 thousandths of an inch. I want it to be 4 10,000ths. That'll be better. And our machine is capable of that degree of accuracy, so why not use it? We are going to come down here, and we're going to do some changes. So we want to uncheck stock to leave. We don't want to leave any more stock. We want to finish this part, so we're going to get rid of that. We're going to skip our multi-axis and go to our linking tab. And we are going to uncheck keep tool down. We don't need that feature. I'll explain that in a later video. We're going to change our sweep angle to 45, and we are going to change down here. We do not need a helix anymore. We just need to plunge in because there's no material here anymore, so now we can plunge in without any worries. But we are going to set our ramp clearance a little more than that, 0.01 or 10 thou, which is better. And that is everything that we need to do. So we're going to hit OK. And it creates our tool paths. So let's go ahead and simulate that and watch what happens. And regardless of what it shows, it's going to do what it thinks is best to make it as quick and accurate a cut as it wants to. So why it does those things, I don't. Those little cuts. It's just the way she goes. But it looks pretty good. I don't see any material left where there shouldn't be. Everything looks good. So, as usual, exit simulation, save our work, and be ready to do the next tool. Alright, so we've now machined our pocket, our cutout, our outside. We have a part, but the edges are super sharp. So remember that we put chamfers on it when we modeled to remove that. Well, now we're going to actually make them. So we're going to come up to 2D, and we're going to click on 2D chamfer. In our dialog box, we need to select a tool. So we're going to select Cloud, Aluminum, and what we're going to use to chamfer is we're going to use tool number 1. And tool number 1, what this is a 1/4 inch 2 flute mill drill with a 90-degree tip. So we can drill with it, and we can also mill with it. And we're going to put a 45-degree chamfer on it. So over here in the dialog box, we have our feeds and speeds. And our mill drill tip is a bit fragile, so we're going to run it a little easy. So we're going to change our cutting feed rate to 25. And that'll make things a little bit easier on the tip. Click on Geometry tab, and we're going to click on everything we want to chamfer. So we want to chamfer this outside edge and this inside edge. We are going to chamfer this guy, but we're going to do it differently. Because if we tried to do it now, it would actually plow into the wall here and crash. So we'll just do those two to start. Go to Heights, as always, model top everything. And 0.4, 0.2, 0.1. We can leave that at 0 and the bottom at 0. So this is where, by removing the chamfer and deleting it before we started this whole process from the model side, makes it easy because we can just do 0, 0. We're going to go to Passes, and we're going to change the chamfer width to 0.1, sorry, 0.01, and our tip offset to 0.05, and our chamfer clearance to 0. Our tolerance is 4 10,000ths, so that's good. And we'll go to our linking tab, and we'll change this to 45 degrees. As you know, I like my 45. And we're going to change our horizontal lead-in radius to 0.025. And that's everything. Let's hit OK. Let it generate. And we can see our tool path is around the edge. So let's go to Simulate and watch it do its thing. So that looks like a pretty decent chamfer. And the one going around the outside. Just knocking off the edge. Now you'll notice if you zoom in though, it's not actually removing anything. And that's because the actual physical model that you drew, I shouldn't say physical, digital model that you drew is still showing. So if we just turn it off here and it goes away, now we see the chamfer as it should be. I'll just turn the model back on for safety's sake for later. We'll exit simulation. Let's just go to our home view. Let's click save, hit OK. Now we need to do our chamfer for this one. I'm going to teach you a real time saver here, and that is if we're gonna create a new chamfer tool. So we go 2D chamfer, but then we have to set it all up. We got to change our model top. It's a lot of work. What we can do is just come here, right click, and do duplicate, and it's going to create a copy of this. And now we can just change a few things, and we don't have to worry about doing all the work. So now we're going to right click and we're going to edit, and no change for feeds and speeds. They're still good. Geometry we do need to change because we've already done that. So we're going to clear it by clicking the X, and we're going to come down and click on our line. Very nice. For heights, this guy is down 1/2 inch, so we need to change this to -0.5. Otherwise, we can't cut it. We're going to come over to our passes, and we're going to change our chamfer tip offset to 0.11. The reason why we're changing that is that it allows us to get closer to this edge, but without touching it. It won't do all of it. There's no way we can, but we'll get most of it. There's no changes to linking, so we can hit OK. And now it's done our tool. So let's click on Simulate, click on Play, and then it does as close as it can get without touching the side of our part. And that looks good. So exit simulation, click on Save, hit OK, and chamfering is done. So the milling is all done now. Now it's just time to drill those holes and thread them, and this thing is done. Alright, now it's time to drill these holes. The first thing we need to do is locate the holes. So every hole goes through the same process. We need to locate the hole, we need to drill the hole, we need to tap the hole, and it's also good to chamfer the top of the hole, break the edge. So in this case, we're going to do things a little backwards. We're going to locate the hole and chamfer the hole at the same time. And I'm going to show you how. So if you've ever worked in the metal shop, you know that once you've done your layout, you need to center punch your hole, because a drill does not like to stay where you want it to unless you actually center punch it to hold the drill bit in place. So you can do that with a center punch. You can also do that with a center drill or a spotting drill. In the case of our CNC mill, we've got a spotting drill on there, and that is the same tool as we chamfered with, our tool 1. So what we're going to do is we're going to click on drilling and drill. And in our dialog box, it's already got tool 1 selected, which we want, which is good. Now we are going to do a couple of changes here. We're going to remove plunge feed rate from 40, and we're going to change that to 10, because again, mill drill tips are very fragile and I don't want to break it. So 10 is nice and conservative and gentle. Then we're going to click on geometry, and we need to select our holes. And there's a couple of ways you can select holes. The first way to select holes is with faces, the default setting. And all we have to do is zoom in, and we have to just get something to show up. So right there, the helix shows up, left click, and it's recognized that hole now. And that's using faces. The other way to do it, and I'm just going to clear that, is selected points. Of course, there aren't any points to select. That doesn't really work. Well, that's because you need to come over to models, and you need to keep expanding until you get to sketches, and then turn on the sketch that you did your holes with. And there's a hole there, for example. So I can select that point, and it'll now drill that. But selecting faces is better because you don't have to turn on all these extra bits in your model. So I'm going to select that face. I'm going to hold down Control. I'm going to select this one, and that's a lot of work. And you can see that this is kind of different now. Why is it different from those ones? So let's clear that selection. I'm going to show you an easy way. Let's select the hole we want, and then click on Select Same Diameter. And it selects all of them now. Perfect. Just saves us a bunch of work. All right. So now we're going to click on Heights, and we're going to do our use. Model top, model top, model top, model top, model top. 0.4, 0.2, 0.1, 0, and our bottom height now we need to specify. So the depth of our hole for this doesn't have to be very deep, just deep enough to make that center punch for all intents and purposes. But we also want to use our brains, speed things up, and what we can do is we can also drill a little bit deeper than needed and put a chamfer that the finished hole will use to break its edge and not be sharp. Now we're using 10/32 thread, so there's some math involved, but let's just say that if we were to drill to a depth of negative 0.105, it will spot and it will chamfer the hole. So we're just going to do that, and then we're going to go to cycle, and we're going to make sure it's drilling rapid out. So that means it's just going to drill straight down to its depth and come out as quickly as it can. And that's all we need. So let's hit OK. And let's click on Simulate. And let's watch it. Boom, boom, and so on and so forth. And there we go. We've drilled our hole, and we've slightly chamfered the edge. You can see some of that chamfer there. Awesome. Exit simulation and save. Now, we need to set up a drilling operation. Does a drilling operation share some of the similarities to our spotting? Heck yeah, they do. This is all the same thing. Same points, same locations. So let's save ourselves some time. Let's right click and let's duplicate. And we'll left click on our new toolpath, right click edit, and our tool dialog box shows up. Now we do need to make a few changes. We're going to change our tool to the proper drill size. We're going to click on Cloud, Aluminum, and we want tool 56, which is the closest drill size I have to a number 10/32 tap. And the holes look much closer. So there we go. That is done. We're also going to change the spindle speed. 4,000 is good. And 15 inches per minute for our plunge feed rate. So we're good there. Geometry is still all good. We don't need to change that. Heights, we don't have to change model top or anything now, which is good. The only thing we have to do is change their depth. Our holes need to be deep. Now, on our plans, our holes needed to be about 380 thousandths deep in depth, but we want to drill deeper than that. We don't want to go all the way through because it's not a through hole. We're going to drill to a depth of negative 0.580, and that's going to give us some room to thread the hole, because if you don't leave some room to thread the hole, it's not going to work. And the threads need to be down to 380. So that's going to give us some room. We're going to go to cycle, and we're going to change this from drilling rapid out. We're going to change this to drilling full retract. And what that means is that it's going to drill to a point, to a depth, and then it's going to come all the way up so that it can remove all the chips and let coolant go in and then drill all the way down again. Kind of like a bird. A bird will peck into the ground, grab a bug, bring its head out, eat the bug, take a drink, and do it again for the next bug. And that's why we have a similar word here, pecking. So pecking is how deep is it going to do each peck into the ground for the bug, basically. So we're going to change this, and we're going to do a pecking depth of 0.05, and depth reduction, we're just going to leave it 0, and our minimum pecking depth should be the same, 0.05, and our dwell is how long it sits there at that depth. We just leave that at 0. We don't need to do that. Do anything there, so hit OK. And now we've got our tool paths for our hole. Let's simulate, see how that looks. Play, boom, 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 boom. It's just pecking away a little deeper each time until it finishes the hole to the proper depth. Awesome. And so that's going to give us a nice hole. Very nice, very nice. Exit simulation. Guess what? Yeah, that's right. Save. Alright, so we finished our holes. Now we need to thread them. We're going to do the exact same thing again because threading uses a drilling operation. And since we've already got it mostly set up, we're going to right click. We're going to go down and we're going to duplicate. And left click on our new toolpath and edit it. So the only changes we need to make are to our tool. So we're going to select our tool now, our threading tool. We're going to go to aluminum, and we're going to look for tool number 19, 10/32 roll tap, Titans. Left click on that, left click on select, and everything is going to populate there. We don't need to change anything. Geometry, no change. This is why we do our duplicate our heights. We do need to make one change. We can't tap to the bottom of the hole. The machine will crash. So we're going to change this to negative 0.480, and that's going to leave us with 100 thousandths space for chips and stuff if it needs to. And we're using a roll tap in this case, and a roll tap doesn't make threads by cutting, it makes them by forming, so there shouldn't really be any chips anyway. We're going to go to our cycle, and we're going to change this to we have a choice of tapping, left tap or right tap. We're going to do right hand tapping because it's a right hand tap, and no dwell at the bottom. And we're going to hit OK. Everything looks good there. So now we can simulate it, and it's just going to do the exact same thing. Boom, 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 boom. And we can see our threads, sort of. It doesn't simulate threads. and exit and save. Alright, so the last thing to do here is just to make sure everything looks good and create a post-processor file. So what I'm going to do is I'm going to simulate everything. I'm going to make sure I set this fairly slow to start. I'm also going to turn off the model so I don't see that. It's just going to show me exactly what the tools are going to cut. I'm going to hit play, speed this up. So basically that's our roughing cut with our face mill. Now that's our finishing cut with our face mill, 10th thou cut. Here comes our tool 4 end mill doing the roughing pass on the outside. I'm going to speed it up just a little bit. Roughing out the cutout. Roughing out the pocket. I'm just going to skip up to the end of the roughing. Everything looks good. Now we're doing our finishing pass around the outside with a contour. Now we're going to do our finishing with the pocket toolpath, cleaning up the floor as well as the walls. Same thing on the cutout. Chamfer toolpaths now to break that edge, make it not sharp. Don't forget that one. Spotting all the holes as well as chamfering, drilling all the holes now, pecking our way. Never drill a deep hole in one full go. And then after this last hole, it's going to tap. Very nice. And that is the end of our OP-1. OP-1 being the top part. We still have to flip it and machine off the hat, chamfer the bottom. In order to do that, we'll have to create another operation, OP2, and tool that. But it'll be fairly quick. It will be easier for us to do OP2 if we could, be able to visually see this, but flipped upside down. And fortunately, we can. So last thing we're going to do here is we're going to right-click on our bottom one before exiting simulation. Click Stock, Save Stock. And we're going to save it as Titan-1M stock. Make sure we have check marks saved to a project in the cloud. This should be your folder. And make sure this is not selected and click Save. And that'll give us a stock that we can load into OP2 and we can visualize it properly. All right, thanks for watching.